Section 3.1, example 5, applying integration by parts more than once. Evaluate sine of ln of x dx. Ooh, okay. So we have an outside function and an inside function. What we could always do is say that this is being multiplied by 1 and then just integrating that. So hopefully we end up with something nice. I do not know how to integrate this itself. Otherwise, we would just go on and integrate it. So this is going to be u, so that way we could differentiate it. So we're going to let u equal sine of ln of x. And we're going to let dv equal dx. So now we have the outside, using our chain rule, the derivative du is going to be equal to derivative of the outside is going to be cosine of ln of x times the inside, so times 1 over x, and this is going to be dx. Over here, the integral of the integral of dv is going to be v is equal to x. Pretty simple. So now let's take a look at the whole thing. The integral of sine of ln of x is equal to u times v. So x times sine of ln of x minus the integral of v du. So v du, we're multiplying these right here. X's divide out, so we're left with just this part here. Cosine of ln of x dx. Not much has changed, so we're going to do something similar to what we did up here, but instead of sine this time, it's going to be cosine. So we're going to let u equal cosine of ln of x. And we're going to let dv equal to dx. So the derivative of u du is going to be equal to negative sine of ln of x times 1 over x dx. Gotta give myself enough room here. And we have v is equal to x. So let's rewrite everything that we have here. Integral of sine of ln of x is equal to x times sine x, or sine of ln of x, minus, then we have the integral of cosine ln of x. So minus, and we have u times v. So that's going to be x times cosine of ln of x minus the integral of v du. So x's divide out again, and we're left with just this part. So minus, that's going to be plus sine of ln of x dx. And now let's distribute this through these two parts. So I'm just going to remove the parentheses here. And that's going to be a minus right there. All right. So I know it looks super complicated and I feel like we're just going around in circles on this part. But what we have are two things that look very, very similar. And I see that I forgot my dx over here. So since we have the same thing on both sides here, what I'm going to do is add this to both sides and potentially moving it over to the left side. So plus the integral of sine of ln of x dx . Over here, these two subtract out. Over here, though, we have two copies of the integral. Sine of ln of x dx. And this is all equal to x times sine of ln of x minus x times cosine of ln of x. I'm going to throw a plus c over here. And one thing that we have, the original question was this: what's the integral of sine of ln of x dx? And here we have that, but we have it doubled. So what I'm going to do is divide both sides by 2. These are going to divide out. But more importantly, we're left with the integral that we're looking for. Sine of ln of x dx. And that's equal to 1/2 x times sine of ln of x minus x, or 1/2 x cosine of ln of x, and plus c. And there we go. It seems like it might be illegal, but this is all completely legal. We found 2 equivalencies on both sides of the equation, and we matched it to something that worked for us. So if you happen to have any questions whatsoever, please feel free to ask. Otherwise, bye.